Chapter 10 discusses quadratic equations. Make sure you have this PowerPoint downloaded so you can take notes during the lesson. Once you've done that, you may begin. The standard form of a quadratic equation is y equals ax squared plus bx plus c. You could also set the equation equal to 0 and say that 0 equals ax squared plus bx plus c. The graph of a quadratic equation is called a parabola. Okay, so the first thing that we need to do is draw a parabola on the graph paper shown. So let's put a dot on the y-axis at -2. Let's put another dot at 0, +1, and -1, 0. And another at 2, 4, and -2, 4. Now again, remember the graph of a quadratic equation is a U-shaped parabola. So we need our parabola to look like a U. Draw your arrows at the top because the parabola does go on forever. Okay? And now let's talk about some definitions. For something to be symmetric, it means that it looks the same on both sides. And when we're talking about your axis of symmetry, we're talking about the vertical line that passes through the center of the parabola. And it's going to go through your vertex, and we're going to define that next. But first of all, in the parabola that we drew, let's draw the axis of symmetry. Draw a dashed line that goes directly through the center of the parabola. And this is your axis of symmetry. And then your vertex is the highest or lowest point on the parabola. Now on this parabola, it is opening up. So we have a lowest point. So this is a minimum vertex, and the vertex is 0, -2. So a parabola that opens upwards is positive. A parabola that opens down is negative. If it opens in a positive way, it has a minimum vertex, and if it opens negatively, then it has a maximum vertex because it does have a highest point. So here's another illustration of positive and negative parabolas. The first, as you see, they're telling you that the A is positive. Well, if we think back to this very first slide where we were discussing, the quadratic formula is y equals ax squared plus bx plus c. So what this is telling you is that if your ax squared term is positive, then it's going to be, you're going to have a minimum vertex. If your a in the ax squared is negative, then you're going to have a negative parabola and you will have a maximum vertex. There are many ways you can find the axis of symmetry by looking at the equation or by graphing. If you have a graphing calculator, you don't need to do all of this work. You simply need to plug your equation into your calculator and find the vertex, and your x value for the vertex is going to be your axis of symmetry. However, if you don't have a graphing calculator, you'll need to use the formula x equals negative b over 2a. So our a in this equation is negative 3, our b is negative 6, and our c is 4. So if we have negative b, the negative stays on the outside of the parentheses, but your b is also a negative term with negative 6. And then your a is negative 3, so it goes in the bottom set of parentheses. Well, a negative times a negative is a positive 6, and then 2 times negative 3 is negative 6, so you get that x equals negative 1. And this is going to continue on to the next slide. Okay, so continuing on from the previous slide, we're going to go ahead and fill in the left side with what we've done on the previous slide. So x equals negative 1. Okay, and then to find the y value on your axis of symmetry, to find the vertex, the second point in the coordinate, you need to plug your x value into the equation. Okay, negative 3 times negative 1 x squared minus 6 times negative 1 plus 4 gives you y equals 7. So this whole thing you can just plug straight into your calculator. Be sure to use your parentheses. So your vertex is negative 1, 7, and it needs to be written as an ordered pair because it is a point on the coordinate plane. Okay, so our a in this term is 1, our b is 2, and the c is 18. Again, we're saying that x equals negative b over 2a. So x equals negative 2 over 2 times 1. So x equals negative 2 over 2, which is negative 1. Plug that back in to your original equation, and you have y equals negative 1 squared plus 2 times negative 1 plus 18. Now it's very important when you plug back in that you plug them into parentheses, because if we did not put this negative 1 squared in parentheses, it would give us the wrong answer. Once you have everything written correctly, type it in your calculator exactly like you see it, and you'll see that y equals 17. In our next example, our a is 1, but if you notice, we don't have a b in this equation. So we're just going to put 0, and then c equals 2. So x equals negative b over 2 times a, so 2 times 1. Well, 0 divided by 2 is just 0. plug that in, and you have y equals 0 plus 2, so y equals 2. Need to write this as an ordered pair, so 0, 2 is the vertex. Okay, so there are many different words that they could use when asking for the solution to a quadratic equation. So if you're reading a question on the SOL, be on the lookout for these different words. They could say the x-intercepts, the zeros, the roots, and of course solutions. Now, your parabolas could have one solution, two solutions, or no solutions. If you have a parabola that only has one solution, that means that it just barely is touching the x-axis, so it's only grazing it at one point. If you have a parabola with two solutions, it crosses the x-axis in two different places, so you have two solutions. And if you have a parabola with no solutions, it's a parabola that never touches the x-axis. If it never crosses the x-axis, then it cannot have a solution. Okay, so I apologize that this did not come out very clear when it uploaded to the computer. However, if you look at the parabola, this is negative 1, 0, 1, 2, 3, 4, 5. Okay? So this parabola crosses the x-axis at negative 1 and positive 5. So what you need to do when you're writing this, you would say that x equals negative 1, comma 5. However, do not put these numbers in parentheses because that makes it look like an ordered pair. And these are not ordered pairs, these are specific x values. In our next example, you can see that the parabola is crossing your x-axis at negative 5 and positive 6. So your answer is negative 5, comma 6. If you were asked to find the roots of this parabola, again, that's just another vocabulary term asking you for how many solutions do you have. And in this problem, you only have one solution, and that is x equals 0. The quadratic formula is the only formula that you're going to be given on the SOL that you've learned in algebra that you do not have to memorize. Okay? It is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. In order to use the quadratic equation, your equation has to be solved for 0 or y. Okay? And an example of what that would look like is listed below. So let's practice on the next slide. Okay, so in order for us to put information into the quadratic equation, we have to first list what our a equals, what our b equals, and our c equals. Well, our a comes in front of the x squared, which is 1. Our b is negative 8, and our c is negative 4. Now we need to plug this into the quadratic equation. Try to write small because it does take some room on your paper to write all this out. So x equals negative b. Now notice that I put a negative on the outside of the parenthesis and then put my negative 8 on the inside. That's very important. You cannot forget one of those negative signs. So plus or minus the square root of b squared, so negative 8 is in parentheses and then square it, minus 4 times 1, because that's our a, times negative 4, which is our c. And we're dividing all of that by 2 times our a term, which is 1. So let's rewrite this in a little bit more simplified form. A negative times a negative 8 gives us positive 8 plus or minus the square root of negative 8 squared, which is 64, minus 4 times 1 times negative 4, which gives us a positive 16 all over 2, because 2 times 1 is just 2. So then we're going to split this up. This plus and minus sign we can't do at one time. So you have x equals 8 plus the square root of 80. I just did the math from here. Divided by 2. And x equals 8 minus the square root of 80 divided by 2. When you're plugging this into the calculator, you need to do everything in the numerator first and hit enter, and then divide that answer by 2, and you will get that x equals negative 0.47 and x equals 8.47. Before we can do the next example, you'll notice that this equation is not currently in standard form because our problem is not set equal to 0. So you need to subtract 10 from both sides, and you're left with x squared minus 6x minus 10 equals 0. Okay, from here you have a equals 1, b equals negative 6, and c equals negative 10. We need to plug that into our quadratic equation. X equals negative b. Now, that's a 6 right there. Remember that you cannot eliminate that second negative sign because b is a negative. Okay? Plus or minus the square root, again the negative 6 for b squared goes inside of parentheses, minus 4 times 1 times negative 10 all over 2 times 1. Okay, so let's go ahead and start simplifying this. X equals a negative times a negative gives us a positive 6 plus or minus the square root. And when we do everything under the radical, so you type this in your calculator exactly like you see it with the parentheses, then you get that is the square root of 76 all over 2. And then we need to separate this. 6 plus the square root of 76 divided by 2 gives you x equals 7.2 when you round it. And then 6 minus the square root of 76 divided by 2 is negative 1.4. All right, so in this example, you'll notice that our equation is already in standard form. So we need to identify our A, which is 2, our B, which is negative 3, and our C, which is also 2. And let's plug that into the quadratic equation. X equals negative B plus or minus the square root of B squared minus 4 A C all over 2A. Okay, so let's simplify this. X equals positive 3 because a negative times a negative is positive 3 plus or minus the square root. And when we plug everything that's underneath the radical into the calculator, now don't put the radical sign in there, just everything underneath of it, including the parentheses, you will find that it's negative 7 over 4. Now, thinking back to previous slides, if you have a negative number under the radical sign, you have no solution. You can't take this square root of a negative number. It's not possible. Therefore, there is no solution to this parabola. And your parabola is going to look something similar to this. It'll look similar to that. So if you graphed this equation in your calculator, you would get a picture similar to that. Now you'll notice that the parabola never crosses the x-axis, and therefore it has no solution. Okay, so we're going to do our last topic, which is simplifying radicals. We have actually already gone over this in chapter 9, but this is going to take it just a little farther. Again, remember that your square root sign is called a radical. When you simplify a radical, it has no decimals. Okay, you might still have a square root sign in your final answer, but you're not going to take it to decimal form. And then how to find your highest perfect square factor steps. First, you need to find the highest perfect square factor under the radical. Second, we're going to rewrite the highest perfect square factor under its own radical. Find the square root of the perfect square and multiply it by the other factor, which is under its own radical. So that's a little wordy, so let's try an example to try to make that a little more clear. All right, so these are the last two examples that we'll be doing on this PowerPoint. And you'll notice in our first example, we have 6 times the square root of 18. Well, 18 is not a perfect square. So we need to think of the perfect square factors of 18. 9 is a perfect square, and 9 is multiplied by 2 to give you 18. Therefore, we're going to put them both under their own radicals. 6 comes down, and we're going to multiply it by the square root of 9, which is 3. And we're going to bring down the square root of 2. Then we do multiplication. We have 6 times 3, giving us 18. We can't do anything with the square root of 2, so we just bring it down. And this is your final answer, 18 times the square root of 2. In the second example, we have 2 different radical expressions being multiplied together. what you'll need to do is multiply the numbers on the outside of the radical together. So 5 times 6 gives me 30. And then you need to multiply the numbers inside the radical expressions together and keep it under the radical. So 30 times the square root of 50. Okay. Now we need to find the perfect square factors of 50. Well, 2 and 25 give us 50. 25 is a perfect square, so the square root of 25 is 30 comes down. Square root of 25 is 5 times the square root of 2. And we actually need to do that last little bit of math. So 30 times 5 gives us 150 times the square root of 2. And that's your final answer.